Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad algebra problem. And here we have 3 to the power of n minus 2 to the power of n equals to 65. And we find the value of n here, but our condition is that our n must be an integer. So that the very first thing we are going to do is here first we multiply and divide the exponent of 3 and 2 by 2, and we write it as 3 to the power of n and its whole power 2 by 2 minus 2 to the power of n and its whole power 2 by 2 equals to 65. And now in the next step, you see here we multiply this 1 over 2 in the n, and we write it as 3 to the power of n by 2 and its whole square minus, here we write 2 to the power of n by 2 and its whole square equals to 65. And now in the next step we convert this nice exponential equation into the simple polynomial equation form in two variables, so that here we take a equals to 3 to the power of n over 2 and we take b equals to 2 to the power of n over 2. And now when we substitute these two values on the above equations, then our above equation will becomes a square minus b square equals to 65. And now this will becomes in here you have a nice square identity. So now we use this square identity, and you know that a square minus b square equals to a plus b times of a minus b equals to 65. So here you remember about a and b. So our a and b both must be an positive integers, because here our a and b are both are complex numbers, and we know that complex numbers always gives us the positive value, so that our a and b must be the positive integers. And now here you focus on the left hand side, we have two numbers which is multiplied by each other, which is a plus b and a minus b. So a and b are positive integers, but in the right hand side we have only one number, which is 65. So now we convert the right hand side in product of two numbers. So we know that 65 equals to 13 multiplied by 5 and 5 multiplied by 3. So here we have two possibilities. 13 times of 5 becomes 65, and 5 times of 13 also equals to 65. But here you see that we have a plus b and a minus b, but a and b are integers. So if you add two integers and you subtract two integers, so it always gives that a plus b is greater than a minus b. So we choose any pair in which our first factor is greater than the second factor. So if you see here we have 13 times of 5, but 13 is greater than 5. In this case our 5 is less than 13. So now we choose here this case only. So now we compare a plus b on this case, and we write it as a plus b equals to 13, and we have a minus b equals to 5. So we have these two equations, and now we can solve these two equations and to find the values of a and b first, and after that we find the value of n. So now when you add these two equations, then you see here this is positive and negative term are gone, and when you add these two and you get here 2 times of a equals to 13 plus 5 is 18, and here we move this 2 to the right hand side and we get a equals to 18 over 2, and 18 over 2 will be equals to 9. So this is the value of a. And similarly when we subtract these two equations, When you subtract these two equations, then you obtain here, after subtraction, we cancelled this a and we add these two terms, so you get here 2 times of b equals to 13 minus 5 is equals to 8. Okay, 8 plus 5 becomes 13, and here you get the value of b equals to 8 over 2, and we have b equals to 4. So we have both values of a and b, and now here we back substitute the values of a and b, so that in the start of the problem, you see here we have our a equals to 3 to the power of n over 2 and b equals to 2 to the power of n over 2. So we back substitute the values of a and b here. So this implies that we have a equals to 9 and b equals to 4, and a equals to 3 to the power of n over 2 equals to 9, and in this case we have 2 to the power of n over 2 equals to 4. So here we focus on the right hand side and we write it as 3 to the power of n over 2 equals to 9, and we write it as 3 square. And similarly in this case we have 2 to the power of n over 2 and we write this 4 as 2 square. So when we compare both of the sides, then we get here n over 2 equals to 2, and in this case we also get n over 2 equals to 2 because bases are same, so that we equate its exponents. And now we move this 2 to the right hand side, then you get the value of n equals to 4. And similarly in this case you also get the value of n equals to 4. So in both of the cases we get the value of n equals to 4. And now we check the value of n, is the value of n satisfies the given question or not. So here we have, this is our given question statement, and now we put n equals to 4 on the left hand side, then you get here 3 to the power of 4 minus 2 to the power of 4 equals to 65. So that here we know 3 to the power of 4 equals to 81 and 2 to the power of 4 equals to 16, and this whole equals to 65. So here when you subtract 81 minus 16, then you get here 65 equals to 65. So this shows that n equals to 4 satisfies this given equation. And here finally we conclude that n equals to 4 be the only solution of this question. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.